All right, welcome Web 19 to your first day with JavaScript. So excited. I'm not kidding. I love JavaScript. It's just nice. It makes a lot more sense in some cases than the things we've been doing. I don't know. I'm a fan. So you've noticed the training kit is way more robust, and that's because JavaScript is the oldest thing as far as our curriculum goes. Our CEO just tweeted today marks our 2 years that we've been in business, which is crazy to think about. It feels like we've been in business for a long time, but I think it's because everybody's careers have led to this, which has been pretty fun. But over that span of 2 years, JavaScript was one of the first things we taught. And so a lot of the things we have in here are matured because they were one of the first things we taught. So if you were struggling with some of the lackadaisical training kit issues in the previous week, and that is because that stuff's newer content, no excuse, but I just love the content we've got here with JavaScripts 1 through 4. So with the beginning, let's look at the objectives. We're going to be studying how to use function declarations, expressions, and arrow functions and describe their differences. We're going to be able to use let const var and describe their differences and demonstrate their differences, actually. Create and use object literals, as well as describe object properties and methods, and arrays, properties, and array methods. This is a fundamental overview of these things. We're not going to be going crazy deep on these. We're going to continue to reveal more as the week goes on, including tomorrow. So this is kind of a get to know JavaScript again in a full-time fashion. You've been doing optional code challenges. You did pre-course work. All those things need to be remembered and refreshed, and that's what this day is for. So this should be a nice confidence boost to your JavaScript kind of day. So make sure you've watched these videos. If you've not, I highly recommend you do. A lot of time was spent on these to help you understand each individual piece. So if by the end of the lecture you're feeling like, or guided project I should say, at the end of this time you should be like, I need to go look at arrays again. Don't watch the 2-hour video. Go watch the 25-minute video. Or go watch the video that's 20 or 15 or 5 minutes instead of the 2 hours. And of course these have code challenges and everything inside of them. So make sure you're using the training kit to its fullest in this week. All right, so what I'm going to talk about first is the very beginning of what we usually teach in JavaScript. So if you notice in our code pen, no need for HTML today or CSS. We're going into the third panel that we've usually ignored for the past 2 weeks. So now it's on. Here we go. So first off, let's start to understand how the browser works with JavaScript. So we've been using the console to test our work, hopefully. If you've not, let's talk about what the console is. The console is inside of the browser. The browser is what you see here. It's an application on your computer. And the console allows us to see some things that we normally would not see over here. So for example, in HTML, it's very easy to see things like, hello. And if we watch, the page refreshes and there's hello. Well, if we were to do the same thing with like a variable, var hello, assign the value of hello. Well, how do we see that? Well, to get it here, it's a little bit more complicated than what we've done here, and that's going to be coming up next week. But for now, how are we supposed to see this value? Well, we can use the console. So here's how the console works. We can say console, just like that, we reference it. It's an actual object that we can reference, by the way, which we'll talk about shortly. And we're going to be using a method, another thing we will talk about shortly, called log. And a log allows us to log the results to the console. And now we can see hello. So the console allows JavaScript developers to test their work. It's meant specifically for developers. Like, you don't put stuff in here for end users. You don't like put sales information in here or something. Like, this is just to help developers see their code and understand it, okay? So we're going to be using the console a lot. Here's the thing. CodePen has its nice little console built into the system. However, sometimes CodePen doesn't throw an error. Sometimes the object's too big to be seen. And so we actually have to jump into the actual console. And you might be going, what? Well, the reality is we're borrowing an interface here. The real console can be found when we inspect element. Remember when we did this all last 2 weeks, basically, we've been living here for HTML and CSS. Well, with JavaScript, we can jump over to the console tab, and look at that. There's the hello. So the console is where we will live and operate. And this is where I recommend you, I want you to spend your time in here when you're writing your assignments this afternoon. Just get familiar with the console and see how it works. We can do all sorts of fun stuff in here. We can even write new JavaScript in here. So we could say like var another thing, assign the value of testing. And now it's going to be actually stored. So we could say console.log another thing. And there we go, it's testing. The undefined, by the way, is happening because the browser is always trying to return something. And if we're not using the return keyword, which we'll talk about shortly, it's going to throw that undefined. Just a little heads up there. It's not broken. Okay, so that's a little jump into the console and how we're going to be using it today. Let's start with the differences between var, let, and const. So hopefully you watched the videos. You've got some semblance of an idea of the differences, and we're just going to drive it home. So I'm going to actually go into my settings, into behavior, and turn off the auto-updating preview because I want to have control. Otherwise, I'm going to get 1,000 errors while I'm trying to write my code because it's just going to refresh every time. So I want to have control with this run button. So I'm going to hit save. I've got the run button. I'm going to go ahead and just delete this H1 so we don't have any distractions. In fact, so you can see here, I've got to hit run for that to work, right? Pretty cool. Then I'm going to grab my console, just go full screen because we just don't need to worry about anything right now. So this is how I'm going to operate throughout the rest of today. All right. So JavaScript is being compiled at runtime, which is totally different than what we just experienced with pre-processing. So if you recall, with pre-processing, we did less. We then went into Node. We then went into CSS, right? And when we ran this compiler, to access this, we had to write a certain code, right? We had to say less, watch, oh man, compiler, less, CSS, and index.less. So this command told our compiler every time we hit save to run it, right? The thing is, it outputted a CSS file, a static file is what we call that. Well, in JavaScript, we're actually compiling this code at runtime. So the browser runs our code, and we call it just in time. So basically, this thing is like, as we write our code, this app is utilizing our computer's hardware to run through and build code. It's pretty crazy. We're not going to get into compiler theory or anything like that, but I just want you to understand that JavaScript is running these things, and that's why it can be so costly to user experiences. And so we want to write efficient JavaScript. We need to know what's going on. That being said, I don't want to go jump into the deep end right now on efficiencies. We just need to learn the basics, right? We're here for the fundamentals. So, but this is interesting because what happens is basically JavaScript runs in kind of a two-pass compilation way. So I'm going to go ahead and delete the last node thing. I don't want it to confuse anybody. I just wanted to show some similarities and, of course, differences. So what happens is on the first pass of the compiler, usually what happens is we're trying to set up a reference. So let's set up a reference. I'm going to say var, we'll call this var test. We're going to assign it the value of testing our var, and then a semicolon. Semicolons are not needed in 90% of the Java, well, 95% of the JavaScript we write. But because of the 5% that they are needed, we usually just write a semicolon. So versus in CSS, if you miss a semicolon, it's going to wreck your program. It's going to make styles bleed everywhere, right? In JavaScript, semicolons are a lot less important, but we write them every time just as a best practice and good habit for the 5% that we do need them. Just a little spoiler there for you if you're semicolon phonetic. They're not as important in JavaScript. So var test, testing our way, or testing our var, I should say. So let's see if this thing works. Console.log var test. Run. And there it is, testing our var. Cool. So let's slow down a little bit and see what's going on here. So var is a special keyword inside of the JavaScript compiler. It's understanding that var is doing something. It's basically storing information for later. We're referencing our var. So by the way, if I didn't have this var keyword, would this still work? Don't run the code. Just tell me if you think. Ooh, I'm seeing some yeses. Why would this work? What do you think? Aha, global variable. Hopefully you read that from the training kit. So in this case, if we were to clear this, save it, and run it, it still works. This is super dangerous because there's no error. Nothing's stopping us from doing this. And this is called a global variable. We want to avoid these. Just like I showed you important in CSS, you need to know what it is so you don't use it. Same thing here. Don't do this. And this happens often on accident, usually in for loops, for example. But in this case, try to always make sure that you've got a definition in front of it. So this is called a variable definition. So we are defining the variable, and then we're giving it a name so we can reference it later. Okay? So this is better than the global that we just saw. All right. Your whole life, you've been saying, at least in algebra and other things in math, equals to, right? So you probably read this in your mind as var test equals to testing our var. I want you to stop thinking like that. I want you to start thinking like this is assign the value of. So in your head, I want you to start seeing a single assignment operator like that and say var test, assign the value of testing our var. Because guess what? We have equals to is triple equals or double equals, which we'll avoid for type coercion, but triple equals is testing for truthiness, whereas a single operator is assigning a value to. So let's get that out of the way now, pull that Band-Aid off, and start saying assign the value of. All right, and so inside of this, we now have a type of data. Now, I'm not going to go dig deep into the types. If you're confused by that, that's something that should be in the pre-course, or you need to Google a little bit more, is just look up JavaScript types. JavaScript is loosely typed, meaning we don't have to declare what type of thing it is. By the way, other languages have to do something like this. Well, they'll say string. So I came from a language that did this. And basically, you're setting up your variable, and then you're using a special syntax to say, hey, this is always a string, and if it's not, throw an error. JavaScript says, you can pass anything you want in here. And I mean literally anything. So if we come over here and we say var test, we could reassign this to the value of 4. Let's see if this works. Save, clear, and run. And it works. Pretty cool, which is crazy because in other languages this would throw an error because of the nature of it. But JavaScript doesn't care. You can put anything in those variables. Notice what I did. Var test allows us to pass in reassign, I should say, a new value without referencing var. And that's because var test was created one time. It was created in memory, and now we can access it again. This is totally valid code, by the way, so no errors. So this is something we have to be careful about, because in JavaScript, we have to remember as humans, like when we're writing these things, what we wrote. There are tools and libraries out there, by the way, like TypeScript, that allow us to protect ourselves from ourselves by basically creating pseudo-strong type languages, but that's for another time. But in case some of you are itching, TypeScript is really interesting. So var test, testing our var. Okay. And then anything on the right side can be assigned. So what's happening here is, what if we tried to console log before var test? What do you think is going to happen? Are we going to see 2 testing our vars, or are we going to get an error up here and then testing our var below? What do you think? 2? Okay, let's see. Save and run. This is interesting. So this is saying undefined. This is running the code we ran. So what's going on here? Well, so some of you are saying not hoisted, but I want to correct you a little bit here, and this is why we're doing this stuff together. So var test actually is hoisted, but what's hoisted? The reference is hoisted, not the value, right? So the left side value actually was hoisted. The fact that we see undefined proves that. The testing our var string was not hoisted, right? It hasn't been assigned yet. So there's something going on here. There's something interesting. So what that means is JavaScript is making an assignment first. So on the first pass, JavaScript grabbed var test and recognized the reference, and so it put it at the top of our stack here. And then what we tried to do is we tried to run console log, right? Well, the problem is it didn't know what to do. So it assigned it the value of undefined. This is proof that there's something else going on under the hood. Undefined doesn't just magically happen. So this is kind of cool. When JavaScript goes through and sets up all the references, guess what it does? It assigns undefined to everything. Isn't that cool? So seeing undefined is actually a really good thing. It shows you the browser's working and that we actually don't have errors. Undefined is usually a user error, meaning we made the mistake. JavaScript didn't make the mistake. I think that's really cool that whenever I see undefined, I actually have comfort. I'm like, oh, I just screwed up. If I don't see undefined, I'm like, oh, crap. Something bigger is wrong here. So get that in your mind that every time JavaScript runs in the compiler, on the first pass, it tries to set up references. On the second pass, it tries to set up values. And so on the second pass, it found testing our var here. And so when we console logged it the second time, it was there because it actually hit it in the pass. Pretty cool. So first pass, references. Second pass, values. Okay. So with that knowledge in tow, understand that every variable, var, let, and const, by the way, they're all hoisted. They're all hoisted inside the scope in which they belong, except we get undefined because of our two-pass compilation. All right, so that's a little bit about var. I want to talk to you about a block of scope. So open, close, and curly braces. This, my friends, is a block of scope. What the heck? What does that mean? So if we have these two curly braces, these are representative of a set-apart portion in our code. I like to think about this in a big kingdom kind of global analogy. So up here, we live on the global scope. So everything everything that we write on this program is considered to be the global scope. I want you to think about this as the world. And then we can go into our little portions in the world. And let's say that this is like this little piece of code here represents our kingdom. So we'll say kingdom. Inside of our kingdom, we have our own set of rules. We have our own set of responsibilities, our own walls and villages, right? We can have multiple. We can even have towns inside of our kingdom. Like we can have little portions of other scope. So we'll come back to this concept further and further even tomorrow. But I want you to think about scope as the way in which we can manipulate the code inside of these curly braces. So if I come in here and say console.log var test, is this going to work? So out here, if I say clear, so this one should say testing our var, right? This should say testing our var again. So if this does work, it should say it 2 times in a row. What do you think? Think it's going to work? Yes, no, maybe so. Okay, let's see. Save and run. It did work. Interesting. So why did it work? Because var doesn't give a crap. So var can work inside of anything we want. Now here's the interesting thing. The reason it can work is because var is accessible on the global scope, meaning anything outside the global scope, anything inside of other curly braces can see outside. So what if we put var test inside? And let's put var test after here, because we already know that if it's up here, it'll be undefined, right? So we've already figured that out with the compiler. But what about this code? I got to put this out here too, otherwise I'll get undefined. All right, here, let's see. Run. It still works. Interesting. So var is uninhibited by the curly braces. This brings us to one of the big differences between let and var. So let me introduce you to our new friend, let. So let, by the way, it's kind of, I mean, var makes more sense to me because it's like variable, right? Let is another type of variable declaration. But let's see how it's different. Let test, assign the value of, testing our let. And let's console log it as well down here. Got to make sure I spell. And let test, cool. Console log, let test. Let's see, it shouldn't be blue. I wonder what's going on here. Okay, let's see if this thing works. Save and run. And there it is, testing our let. It does indeed work. Okay. So what's different? Like, it looks identical to var except for the LET instead of the VAR. Well, here's where it gets interesting. Let's take that let and pop it outside the scope and see what happens. Save and run. var worked right here. Let worked right here. var worked right here. And then we get blank. This is where the code pen console is not good enough to see what's going on. So we've got to go to the real console. And we get a reference error. Interesting. So in this case, let test is not defined on the second time that we try to define it. This, my friends, is because of a thing called block scope. Remember how we talked about the kingdom? So in this case, the kingdom is preventing let from leaving the kingdom. It's stuck inside the walls of the kingdom. It won't allow it to go out. So let is limited by this block of code. So if I were to write some notes out for you, they would look like this. So var is function scoped. So we'll talk about what that means very shortly here. Can be reassigned and can be redeclared, which is crazy, and we'll talk about that shortly. var is just crazy. If we go to let, it is block scoped. The value, or let's say the value is mutable. So we'll use the same language across the board here. The reference cannot be redeclared. So those are some key differences. Let's talk about those. So with var, we basically can do anything we want. In fact, we can rewrite the var. So watch this. This is crazy. var test, or say var test, and then we just overwrite this and say, this is bonkers. Guess what? This is valid code. So you can actually rewrite the whole thing, and it's as if this line didn't even exist. That's how crazy var is. So if we hit clear, save, and run, you can see this is bonkers. Our let comes in. This is bonkers. So this proves that var can actually be rewritten, which is just like, wow, that's scary. So that means that you could be writing some really important code. If you forgot the name of another variable that you wrote and they were visible in the same scope, say goodbye to the original thing you wrote and without any errors. Ooh, that's scary. And that's how we lived for a very long time. That's how I lived for a very long time. So you always had to watch your vars. So the good news is, because we're living in a new browser era with new ECMAScript standards, we don't have to worry about using var anymore. So much so that it's actually bad practice to use vars because of this exact behavior. So we don't use vars anymore. So avoid using. If we come into let's pretty cool. The only thing about let is it has mutatability in its value. What I mean by that is, if we come down here and we say, let test, we assign the value and say, I am mutable. Mutable is a fancy word to say that we can change things, and it's going to be okay. So I'm going to go ahead and get rid of this so we don't have any more errors, but let's see what happens. Save and run. So notice that we first set up our pass to say, or sorry, on our let to say, nesting our let, right, or testing our let. And then we changed it to say, I am mutable. Notice that the final value came out, I am mutable. All we did was reassign the value on the right. Notice that we didn't redeclare let, though. If we redeclare let, let's see what happens. Save and run. And we get an error. If we look inside of our code, console, identifier let test has already been declared, Josh. You can't do that. That's a good error. That's telling us that we can't redeclare that. It's very good behavior because it prevents us from accidentally overwriting our own code. Okay? So there's one more variable type that we're missing, which is const. And const looks like this. Const test. I am a const. So const is short for constant, which is nice and easy to understand. In this case, const test performs exactly the same things as let. Like we can copy and paste this. Except it has one change, which is the value is immutable, meaning you should not be able to change the right side of the operator without an error. So if I were to come in here and say console.log, and I had my const test, go ahead and get rid of this for a second. Save and run. You can see this is bonkers from our var. I am mutable. I am a const. So let's see if we can update const to be mutable. Say, I am immutable. So let's see if we can even see that line of code. Save and run. And you can see the whole thing errors out. Big time error. So this is stopping everything. We look at our console and it says assignment to constant variable type error, meaning this type of variable does not allow this behavior to occur. So why in the world would you want to use const if you couldn't update the value? Well, interestingly enough, you're not usually updating the value of your variable so much as you're holding it for later. So best practice, at least at Google and other places, and we emulate that here, is always use const until you can't. Okay, so at Lambda School, that's our recommendation, is use const until you can't. So, and in that case, you're going to end up using let, but never var. So that's how I want you to all operate and start thinking, is your new variable overlord is const. And you're going to follow that until you can't use it anymore. Okay? So if we come down here, var let and const, it's block scoped, the value is immutable, reference cannot be redeclared. So consts are super safe. They protect us from ourselves and our own code. Okay, so one thing that I talked about, and this will be the last thing, and I'll open up to questions after this, and we'll take a break, is how do we see the function scoping of variables? And so, because in this case, everything, if we try to write a const out here, by the way, so if we tried to get this const to show up down here, it's going to have the same error. It's just not even going to reference it. So if I come in here and say inspect, you can see const is not defined. It's living inside of the scope of kingdom. So kingdom is not letting anything see it. So that proves, again, const is block scoped. So every time you see a curly brace, I want you to think in your head, that is a block of scope. Like that is, nothing is going to get out of there if it's a let or a const. And that's actually a really comforting thought. Versus var doesn't give a rip. So if we came out here and console logged it, it would work. So we've got to control var. Well, how can we control var? Well, I think of function as a guard. It's not letting var out of the block. It's not letting var out of the kingdom. So if we were to write a function, so let me go ahead and write a function down here, because that's the next thing we're going to talk about. And we're just going to say, you know, stop var. I want you to notice something. We've got ourselves a block of code here, but this time we've got a guard in front of it, and its name is function stop var. So if we come in here and we say, now let's declare a new var. We'll say var escape, assign the value of I want out. If we were to console log this, first off, I'm going to go ahead and comment these out so we don't get extra logs. But if I come down here and try to log this, is it going to work? So if I hit run, are we going to see I want out? What do you think? Okay, I'm going to hit run. Nope, nothing happened. That's right, Amanda. I have not called the function. So when we call functions, there's a fancy word we use. Does anybody know what that fancy word is? Invoke. That's right. Whenever I think of invocations, I think of a wizard with their JavaScript book, and they're going through and they're trying to find the spell they need, and then they go, stop var, I invoke thee. And then all of a sudden, magic happens. I do that because it's ridiculous. It's ridiculous to say that, and it helps me remember the word invoke. So in this case, we are invoking the function, aka calling the function. So what I mean by invoke is that it's been declared, it's been defined here. And so what we're trying to do is actually wake it up, use it, right? Invoke it. So in this case, stop var needs to be invoked. And the way we do that is by using these parentheses here. So these parentheses trigger inside our compiler the invocation of stop var, which is a function declaration. Okay, let's see what happens. Save and run. I want out. Okay, it worked. So here's where I want to see if this gets interesting, if we can understand this. If I put a console log here of escape, which is housed inside of stop var, notice that I'm invoking it first, so there's no tricks here. Do you think I want out will show up or not? Okay, here we go. Let's try this. Save and run. So in this case, it says function escape native code. If we open this thing up, is escape part of native JavaScript and I accidentally named it something? That'd be kind of funny. So if we come over here and change this to say, you know, something else, let's see what happens here. Save and run. Let's see. There we go. That was just happenstance with escape. I probably shouldn't have used that keyword. So in this case, something else cannot escape. Why? Because it's function scoped, meaning the function keyword is guarding the var from escaping. It's not allowing it to escape. Benjamin says, you need a return statement. Let's try that out. Return something else. Save and run. What about that, Benjamin? It's not showing us the something else inside of here. That just shows you that var cannot escape, right? So we're going to talk about how we could return that value. So you're actually not wrong, Benjamin. It's just we got to call it a different way. Well, let's come back to this after the break. So let me answer some questions, and then we'll go to break. I don't fully understand the functional difference between reassigning and redeclaring a variable. Okay, let's talk about that. I think it's a great question. So the functional difference is, you see this keyword var here? This is called a redeclaration. We're redeclaring var and var twice. It's as if this first one didn't matter because this thing is totally overriding it. Versus a reassignment with let test is simply updating the right side value. So a redeclare is the left side and right side value. A reassignment is just the right side. So hopefully that clears things up for you. Now that it's best practice to not use var, are there any good cases for var? No. Anything that var can do, you can do with let or const in a controlled way. So there are, of course, fringe cases where super JavaScript developer fights happen. But they're so fringe, they're not worth talking about. Let is mutable versus all primitives are mutable. For example, they cannot be altered from MDN. Confused. So, yes, we've talked about this. Let is mutable, meaning the values can be changed, right? So don't get caught up in the weird, keep jumping over here, the weird nature of it. Remember, const is the only thing that is immutable. So const does not allow updates to the right side. Except we'll see one little gotcha shortly with object literals. On Stack Overflow, I always see var declarations. I look into it, and it seems that ES5 is still heavily supported. Should we use ES5? So the reason you see that is because you see a lot of developers that for a decade have been using vars, and they just don't care. So that's why. But you, as shiny new JavaScript developers, we're going to give you best practice opinions when we have access to var, let, and const. Are there times when you need a variable to be in the function scope as opposed to the block scope? Nope. And that's why you need to know the difference. But there's not a time that you need it right now. What do you mean by right side and left side? So what I mean by that is the right side of the assignment operator. So the assignment operator to me is the great divide. Everything on the left is like the reference. So it's like var test is like a reference. We can go look it up in a phone book, for example. The string or value on the right is the thing that we want to do. So for example, if you looked up Lambda school in the phone book, you're looking for Lambda school on the left. And then once you find it, you find the phone number on the right, and that's going to be the value. So left side is the reference, right side is the value. And the middle is the assignment operator. So when I say left and right, now you know. Okay, let's take a 5-minute break. When we come back, we'll jump into functions. Okay, break time is over. Let me see if there's any last questions in here. What is a phone book? That is something that I don't know if a lot of people know what that is anymore. Or floppy disks. Those are two things you'll have to Google. What about function objects? Does let apply to those, or do you need variable? We'll talk about those right now, actually. And those are called expressions, by the way. So let's jump right into that. So over here, we've got the beginnings of functions. So functions. And I used functions to help us describe the difference between varlet and const, but let's not overlook how powerful functions are. In JavaScript, functions are considered to be first-class citizens, meaning functions are just as important as objects, whereas in other languages, functions are not. They can't be passed around. We're going to see tomorrow that we can pass functions around as parameters. So first off, what the heck is a function? Well, it's kind of like I talked about as a guard statement. That's really helped me identify what functions are. They protect a block of code until invoked. That's a great way to think about functions. There's different types of functions and different use cases for functions. I want to talk about 3 different types of functions today. So number 1, this is called a function declaration. So what I've done is I've declared a function. So let's see if we can reference this. So I'm going to take stop var, and can I reference the function before I get to the function? What do you think? This is an interesting one. Some people are saying yes. Most people are saying yes. Some people are saying no. And people are saying hoisting. Okay, let's see what that means. Save and run. Well, we don't have anything in here, do we? So I got to say, by the way, let's use the return keyword. So the way to invoke this is to say console.log. Then we'll invoke stop var so we can see if that return statement comes back. Okay. Save and run. By the way, going back to what Ben said, so remember when Ben put himself out there and said, yes, it would return? And some of you were like, what up now, Ben? Emmett. Well, guess what? Ben was right. We just got to make sure that we invoke it correctly. So in this case, stop var is being invoked inside of console log, and that's where the return statement gets happen. So good job, Ben. So in this case, it says, I want out. Sudoku. I can't right now. Okay, function stop var. We've got what's happening here is stop var actually works because here's what happens on the compiler. The reference to stop var is brought to the top of the scope. And this bringing to the top of the thing, remember how we talked about that 2-pass compilation briefly? Let's talk about it again. So on the first pass, what does the compiler find? What does it look for? References, right? And then on the second pass, what's it trying to do? Values. So on the first pass, it tries to find references. So stop var is referenced. Well, the cool thing about functions is they're just placeholders for the stuff inside them, right? Like we just talked about that. So it actually makes sense that stop var was brought up here first by the compiler. So it's as if it already existed. And then once we console logged, the reference was there and it went inside and did all its work. So that's why this actually works. Kind of interesting. So that is the concept of hoisting. It takes variables and functions and brings each of them to the top of their respective scopes. Notice that I just said respective scopes. That means that this var is stuck inside of this scope of code, right, until we return it. So if we didn't have a return here, you're right, it would not go out. So keep that in mind, that scope is a big freaking deal. So these curly braces are a big deal. And now you can probably start to understand where if you've heard some JavaScript and other developers say, don't use globals if you can help it. Now you understand why, because if I have a global up here, so notice we don't have any globals right now except for like our function reference, because these are all trapped inside of this piece of code, right? But if these were all outside here, those would be considered global and could be referenced by any function. Super dangerous, right? Because we could accidentally call them if we forgot their names, for example. And then we can get all sorts of crazy stuff happening. So imagine 8,000 lines of JavaScript over an app and trying to think, I will never rename something, right? There's going to be issues, like we're humans, we make mistakes. And so if we can at least follow some rules, that'll help us mitigate mistakes. Okay, so in this case, a function declaration is hoisted to the top of its scope. So let's talk about the return keyword. So the return keyword returns something back to wherever it was invoked. So there's that fancy word again, right? Invocation. So in this case, we invoked stop var, we called stop var, and stop var said, I'm going to return something else to you, which was I want out, right? So in this case, this is kind of a silly example. Maybe let's turn it into something a little bit more valuable. So I'll keep this here because we were using var, but let's make another function declaration. And I'm going to call it add. And we won't worry about like a var here. But inside of an add function, we probably want to return two values, right? So I'm going to put num1 here and num2 here. And then I'm going to return a value of num1 plus num2. So you can see how return statements are even more powerful because they can actually return something that's being operated on. That's pretty cool. So let's see how this works. By the way, even though hoisting does exist, it's best practice to always try to log or do something after the function, just so it's readable. You can read down your code. Okay, so I'm going to go ahead and comment this out because we don't need to worry about it anymore. It served its purpose for future references to function declarations. So let's move down to add and see how this works. So we're going to say add. We're going to invoke add in here. So I've got to add something together, right? So I'm going to put two numbers, 2 and 4. What are these two numbers called right here, like in the context of the invocation? Okay. I'm seeing mostly arguments and a couple people thinking they're parameters. Let's make this super clear right now today. These are not called parameters. These are called arguments. When I first started, I thought they were parameters too, because I got confused all the time. But let's get rid of the confusion. These are arguments. These are parameters. So we'll say the values being passed into the function are called arguments. The placeholders that receive arguments are called parameters. Okay? So in this case, num1 and num2 are called parameters. There's a huge difference here. Arguments are like actual values. Parameters only care about which order you brought them in. The name doesn't matter at all. So if I were to change this to like blah, 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 if I were consistent, it would work because it's just a placeholder. The name does not matter. And I think a lot of developers, I know when I first started developing, I thought parameters had to be named a certain way. They don't at all. It's all about order. So let's see if this ridiculousness works. So I'm going to go ahead and say clear, save, and run. Before I hit run, let's do 2 and 4 and see what goes on. So 2 plus 4 should be 6. We got it. Proof positive that the parameter name doesn't matter at all. Not one bit. So as long as we're consistent, that's all that matters. Okay, now what does matter is the next developer, right? So things that drive me crazy are names like this that make no sense, super short names that also don't make any sense. So the happy medium in between is to kind of tell the next developer what you're trying to do by kind of giving them some information and not just concatenating everything. Back in the day when we didn't have minifiers, a lot of developers got in the habit of coding like this, which is fine. I get it. And because of the function, it's so tiny, it's readable, it makes sense. But when you start getting into bigger functions and more complex apps, this can be awful spaghetti code where you're just trying to map up. And what are they doing? They're just going down the alphabet because they haven't taken any creative freedom. So this stuff can be maddening later on. So I want you to get in the habit of trying to help the next developer, including yourself, understand what's going on next. So num1, num2 make more sense because you're expecting to receive numbers. Now, JavaScript's funky, doesn't care what you pass in. So what if I put 2 strings in here? Like what and up. Is this going to throw an error or anything? Or what it's going to return? Fancy word. Let's talk about what that means. So if we come over here, it says, what up? Now what if I put white spacing in here? Like, what? Is it going to give me that space? Indeed it is. It respects white space because it keeps it as a value inside the string. So strings obviously can be passed in as well. And tomorrow, we're going to look at how functions can even be passed in as arguments. That's the crazy thing. So hold on for tomorrow. So in this case, we'll go back to 4, but I just want to showcase to you that it doesn't have to be numbers because the plus sign here can either add things together or do what's called concatenation. And concatenation is simply put, jamming 2 strings together, or not just strings, but jamming 2 values together. Okay, so we've talked about function declarations. We now understand that these are arguments, these are parameters. We also know that the return keyword is returning something back to the function that declared them, or to the invocation, I should be specific. So, can I write any code after the return statement? Will it return? Let's see. Save and run. Good job. I'm seeing all of you saying, no, it terminates. So the return statement is terminal in that it does not allow anything to run after it's been declared. You can put a bunch of stuff in here, though. You can put a bunch of extra code in here, not just one little plus sign. But after that semicolon there, it's going to kill everything. So the return is lethal afterwards. So I have in the past totally forgot this in the furious writing of code. I'm like, what's going on? Nothing's working. And it doesn't give you an error, by the way. It just doesn't return it. And if you look closer, you're like, oh my gosh, I put my return statement too soon. That's going to happen to you, guarantee, once or twice in your life, maybe 10 times. Okay, so in this case, we have the add, and we have a function declaration. So let me now talk to you about, let's see. I'll put this up here as well with the invocation note. There we go. And now we're going to talk about function expressions. So function expressions are interesting in that we can actually bring back our old friends, var, let, and const. That's right. We can house functions as values. What? Okay, let's see this in action. So remember, we want to use const until we can't. Function, expression, test. That's a long one. We'll just get rid of the test. But it doesn't have to be called function expression. I just want to make that clear. So function expression, now in a normal setting, like this is what we understand a variable to look like, right? Well, guess what? We can replace strings with actual functions. But here's where it gets a little crazy. Because we know it's going to be a function, and because we already have a name over here, we don't have to rename it again if we don't want to. And I'll tell you what, 10 times out of 10, you don't want to. You don't need two names. You don't need confusion in your life. So here's what we do. We write things called anonymous functions that just go right into the invocation of their block of their code. So remember, a function declaration is like has a name here, right? That would be ridiculous to have two names for one function. So we don't need that ridiculousness. We can just assign the value of a function that will then execute. This, my friends, is called an anonymous function because it has no name in the declaration. However, we did name it over here with the const, so is it truly anonymous? So in this case, we call these little ditties function expressions. So let's go ahead and do the same kind of stuff we were doing with add. So let's bring in num1 and 2. Let's return num1 and 2 just to see, so it's 1 to 1 here. And let's see how this works. So I'm going to say console.log. I'll say function expression add. How about that? We'll make it more applicable. I'll throw it in here. I'm going to go ahead and get rid of my log here so I don't accidentally invoke a function. Okay, so clear, save, and run. Let's see how this works. The same way. Works the same way. Awesome. So in this case, function expression add is doing the same freaking thing we were doing with add. So why go to all this work to confuse ourselves to put in these things? Well, it's because when we have a function that's housed inside of a variable, we can actually use it in a more compact way. We'll talk about more of that tomorrow with callbacks and higher order functions. But for today, I just want you to kind of get used to seeing this and calling it what it is, a function expression. Now, something very interesting. Can I log the result up here before I get to my function expression? No, why not? But wait, I told you all variables are hoisted inside of their scope, and we are on the global scope. Okay, let's find out. Save and run. And we get an error. So if we go to our console, function expression is not defined. Oh man. But notice something here. It's a reference error. So remember, it's not, what is the reference? Is it left side or right side? Left of the assignment or right? So in this case, it's looking at the left side and saying that it's not been defined yet. So we have to be careful about these things because consts, let, and vars are going to throw up that error. Now, what if I change this to a var, by the way? Do you think that's going to change the error? What do you think? Run. Go back in. Console. Same problem. But look at this error. It's a little bit different. Type error. Function expression add is not a function versus a reference error. That's pretty crazy right there. Those are two different types of errors. So in this case, var function expression add is saying that this is not a type of function. So don't get caught up in these things, but I just want to point that out and say that could be some good Googling for later. For now, notice that we're using const to do these things. Okay, so function expressions allow us to do something even more unique, which is called an arrow function. So arrow functions are derived from function expressions. So some of you might know about arrow functions. They're becoming more popular in their syntax and usage. I personally am not a huge fan of them, but I love them in certain scenarios. Other developers use them for everything. Most of the code you're going to see in the future uses them for everything. All right, so here we go. Arrow add. So what I want to do is I'll go over here and console log this, invoke arrow add. Okay. So before I do anything, let's make sure this thing's running correctly. Save and run. 6. Okay, we're good. So inside of here, I want to convert a function expression into what's called an arrow function or a fat arrow function. Let me show you how simple this is. You simply delete the function keyword, and on the right side, throw in an arrow. And that's it. That is an arrow, that's an arrow expression or an arrow function. That is the simplest conversion we can do. Let's see if this still works. Save and run. Works. Awesome. So here's the thing. There is way more to this than meets the eye, but I just want you to focus on what I did here. I'm using a new version of ECMAScript. Okay, just like varlet, so let and const, by the way, are new versions. They're just newer versions of Java's ECMAScript. By the way, ECMAScript is the standard in which we are writing. We're using JavaScript to write that standard. So you know how in HTML, there's HTML5, right? We talked about that in doc type and all and semantic tags and all that stuff. Well, ECMAScript is the equivalent of HTML5 as far as standards go. So if you were thinking, we're writing in JavaScript, well, you are, but you're following the ECMAScript standards of writing JavaScript, which all the browsers are subscribing to. So be careful in the way you think. We're actually writing in ECMAScript standards. Okay. So in ECMAScript standards, the compiler is following those rules, and the compiler is looking for special symbols. In this case, the compiler looked for this symbol, the assignment operator with the alligator. So in this case, we call this the fat arrow because this would be a skinny arrow versus a fat arrow. So skinny arrows are not understood by the compiler. In this case, notice everything breaks. The fat arrow triggers in the compiler, hey, I'm an arrow function. Okay, a lot of you might be going, why in the world? I mean, it's a little bit shorter than that, right? Like tiny bit. But there's a lot more things we can do with this. For example, we can actually remove the return keyword and the curly brace, and we can actually do that. That's valid code. But I'm not going to do that right now. We're not going to worry about that stuff. But I want to show you that arrow functions can go way deeper, and I've got a nice Medium article for you to read in the training kit regarding arrow functions. But for now, I want you just to get in the habit of converting these things down. I would be remiss if I didn't tell you why arrow functions even have value, which is the non-binding of the this keyword. That's all I'm going to say for now. Let's just hold on to that thought for later in the week. So in this case, arrow function, take out the function keyword, and know that it's derived from a function expression. We can't talk about this keyword right now, Matt, but we will on Wednesday. Okay, so arrow functions, get used to just seeing them. You will see them more. And I found in the past when I did not teach them, that students got totally lost in the future. And so now I want you to be prepared for the future by at least being exposed to them on day one. So there you go. Arrow functions are derived from function expressions. And that's all we need. Okay. Let's see. Let's take another 5-minute break. When we come back, we're going to jump into object literals and arrays. So 5 minutes, and I'll answer any questions. All right. Break is over. We've got so much content today. I've kind of been cruising through it and I haven't given you a lot of opportunities to ask questions as quick intervals. So let me go back here. What's the benefits of using function expressions over function declarations? Mostly it's going to be mobility in our code. So being able to pass those references around. So it's like, hold on to that thought. We're going to talk more about that tomorrow when we start talking about callbacks and higher order functions and array methods. They'll all start to become more clear as to why function expressions are really powerful. To clarify, an arrow function is a derived version of an expressive function? Yes. Meaning you cannot have an arrow function that is derived from a function declaration. Like you would have, it doesn't work syntactically, but they do work syntactically from a function expression. If one is supposed to always invoke a function after it is declared, why is it important to know that a function is hoisted when it's not? So the answer to that really relies on just your solid understanding of JavaScript. That's really why. I just want you to understand that there's a compiler happening, hoisting does occur, and just in case you need to use that feature instead of having it being a bug. So knowing when a feature versus a bug occurs is my answer to that question. But why? Why does JavaScript need to have these different function declarations? I feel var my function do something is good to be sufficient for most things. So var my function is a function expression. You don't need to always have a function expression. You could just be running a function inside a block of code, for example. No need to pass it on for later. So, but you're right. I mean, if you wanted to go fully function expression, you could. But there are values, specifically to this keyword, by the way, which we'll talk about on Wednesday, why they are different and good. How do you delete in place? Not sure what that means. Sorry if you could expound. Can we go over arrow functions one more time? Sure. So just really quickly, if you look at these, they're basically the same function, right? It's just I changed the name. So if I were to convert this back to a function expression, then not an arrow function, I would delete the arrow symbol, go to the front of my parameter holder here, and just write function. So if we were to convert it back to an arrow, you delete the anonymous function name, and you reintroduce this arrow. The compiler understands this to be an arrow. You just need to understand the syntax looks like this. So when the compiler sees this arrow, it goes, oh, I know what to do now. If this arrow wasn't there, you can see everything breaks. So that little symbol really is the crux of arrow functions. And that's it for now. There's other things we can do with this later, but for now, this is as far as I want us to go. Okay, so let's move into objects. So you've probably heard from Medium articles or YouTube videos or other things about JavaScript. Everything is an object in JavaScript. And that is very true. We're going to be talking about what that really means in the coming days. But for now, I want you to understand what an object is. In a lot of ways, objects are just fancy variables, but just fancy ways to contain more information. So we're going to call these things object literals. That means we are literally writing an object instead of inheriting from it abstractly. So what does all this crazy stuff mean? Well, let's go write an object. So const, we're going to always use const until we can't, right? So that's why we keep using it. We're going to talk about an object here. I'm going to make an animal object. So I'm going to say const animal like that. I'm then going to use the assignment operator. So everything up until this point looks like a variable. That's why we spent so much time on variables, really understanding that syntax. But here's where things get different. So remember how I told you can jam anything you want inside the right side of this operator? Well, we've already done functions, right, with function expressions. We've done strings, we've done numbers, and now we're going to add another thing to our list of things we've jammed inside of a variable, which is a block of code. That's right. We can actually put just a straight up block of code inside of our variable. And when we do this, this is often called an object literal. And so what that means is we must follow the rules of what an object is. So every object has two main portions of how it's built. The top part is a thing called key value pairs, and we call these properties. And then there's another portion, which is the functions, which we call methods. So functions of the object, key value pairs of the object. So these are the two portions, the anatomy, if you will, of an object literal. So let's go see how these things work. So the name value pair, key value pair, we call these, is a pair. It's a pair of data. So on the left side, we have something like name. On the right side, if this was any animal, we'll just call it zebra. And I want you to notice something interesting. Instead of a semicolon, I'm going to be using a comma. A comma is basically saying and I want to do something else, and I want to do something else, right? Just like in our parameters. So up here, we've had a comma, right? And this comma is saying num1 and num2. Well, inside of an object literal, when we use comma, it's the same thing. So now I'm going to add in some different name value pairs. I'm going to give it a weight. Spelling is so hard for me. 100, a height. These are all just arbitrary numbers, so don't hold me to any of these. I'm just making this stuff up as I go. Habitat, and we'll put in a string, planes. So everything here has been like safe, right? We've got a string, we've got numbers. Well, here's where it's going to get a little bit crazier. We're going to go down to the second portion of what really makes an object literal, and that is functions. So I'm going to make a function called eat. Now here's the thing, I can use the function keyword anonymous function, remember that? No name, because it's being set up with a reference over here. I'm going to open and close some curly braces. This syntax right here is called a method. So I think for a very long time, I was confused as a new developer between the difference of a function and a method. It was so confusing to me. I want to make this very clear to you. A method is a function housed inside of an object. Okay? So a method is a function housed inside of an object. Remember when we said console.log? Remember this interesting syntax we've been just kind of taking for granted this whole time? Well, guess what? Console is an object, just like animal. And log is a method, just like eat. Isn't that cool? And then it does something with the insides. In this case, it outputs things to the console. For us, our function eat is going to return something as well. We're going to say return, and we can return a string, and we can say, this zebra or this animal likes to eat grass. Okay, so let's see how this works. Just like console log is working, let's use our zebra. So we're going to say animal, because that's the name of the object, right? We're then going to use dot syntax. So dot syntax is our way of accessing these values inside of here. So the left side of our colon, by the way, is kind of like our assignment operator here. So the left side can be accessed using dot notation. So animal dot, and then I could say name, weight, height, habitat, or let's do name first and see what happens. Now, before I hit anything, is this going to work? Well, I see something show up in my console. Let's hit zebra and see what happens. Wah, wah, we got 6 because we got our arrow function still running. But remember, JavaScript needs something, otherwise we can't see it. So we're going to go ahead and borrow this console log again. But I want to talk about that word invocation. Are we invoking animal or are we referencing animal? What do you think? Are we calling animal or are we referencing it? That's right, we're referencing it. But we will call something inside of animal soon. Okay, so I'm going to hit clear, save, and run. And now we get zebra. Pretty cool. We can come in here. We could do a comma, say animal.weight. If we wanted to check out both, save and run. Pretty cool, zebra and 100. So you can see how this could be really valuable because variables are just one shot, right? Like variables, const, let, var, they're all just holding one value. So they're very limited. Whereas object literals, you can hold unlimited amounts of values. Whoa, that's crazy. So they're like super variables that can hold n amount of properties and n amount of methods. Pretty crazy. So in this case, we've learned that we can use dot syntax. So let me console log something else. So we've got name running, it says zebra. But what if I wanted to invoke the method? Notice how I said that, not function. I wanted to invoke the method eat. So what I can do is I can use dot syntax just like we're using here. I can use here. So I can say eat. Is that enough though? Can I just say eat? Well, will this run? Or do I need to put those parentheses on there? What do you think? Let's hit run. Interesting. So in this case, it returned the definition itself, but didn't invoke anything. So those invocation parentheses matter big time. So if I put these in, let's see the difference between the two. Save and run. And this, my friends, is the difference between invocation and just calling the reference. So invocation, again, is calling it. Remember the wizard book and all that stuff? We're invoking a cell eat. So in this case, it's kind of a cool thing to see the difference between the function declaration that's giving us the reference and the invocation. All right, so we can do this n amount of times. When I say n, that means unlimited amount of times. You can put as many properties you want in here. You can put as many methods as you want in here. By the way, if you want to put another method, it's the same thing as far as syntax go. You just put a comma, and away you go, just like anything else. So it's not like anything special there. You just follow the same syntax. And in this case, we said run, and then we could say this animal runs fast. And so if we came down here and we console logged run, you can see what happens here. So save and run. Zebra, this animal likes to eat grass. This animal runs fast. So I'm just showcasing to you that you can put as many of these name property values, key value pairs, I should say up here, that are called properties, and then our methods that are functions. Okay, so in this case, this is it. But now I'm going to show you how this is so important inside of our documentation. So let's everybody go here together. Let's go to MDN. MDN is considered to be right now the best resource for ECMAScript standards, JavaScript, for the web. And so this is considered to be the de facto JavaScript documentation on the internet. And I tend to agree. So let me give you a little tip and a trick on how to best use the documentation here, and how to read this documentation. So for example, let's say we wanted to learn about objects. So here's what I would Google if I were you. If you tried to type in objects, let's see what happens. You get this thesaurus, or depending on whatever your Google searches are, but you'll get all these things that are not very helpful to you. And maybe they're not defined in JavaScript. So if you've not been using Google very much before you came to Lambda School, let me teach you how to use Google a little bit better. So it's wise to put in the thing that you want in front of it as a filter. So you can say MDN and then type in objects like that. And you hit enter, and then for sure you will get an MDN reference or a JavaScript reference instead of just getting objects and a million results. I know it seems like a no-brainer, but I did not have anybody tell me this when I first started using search engines. And I would just type in stuff all the time like objects, functions. And then all of a sudden I was reading Java documentation on accident. And so that's why you're here, right? To get these little tips and tricks and become a better developer. So MDN allows you to filter it beforehand. Okay, so let's go look at MDN and see how we can actually read this crazy site. So when I first saw this, I was just like, oh my gosh, this is ridiculous. And in some ways it still is ridiculous without anybody guiding you on like how this stuff works. Like objects are crazy. I can't believe I just Googled this. Like, I don't know what I'm looking at. So let me help you reference the documentation and become better at reading it. So all MDN documentation has the same structure, at least for JavaScript, regarding objects. So watch this. On the left, MDN always has properties listed first and methods listed second. That's something you can always count on when it comes to MDN. And if you didn't know that, now you know. Also, on the left here with properties, you can see some things that have been depreciated or no longer being used. They've got a trash can or a warning sign. They also have little icons here that tell you if something should not be used. So really, we're talking like the base object here. It's not very helpful. We'll get into arrays in a second here. But you can see we've got some methods. That means we should be able to use these on any object. Okay, let's go click on entries, for example. So you can see we're still over here with properties and methods. Nothing's changed. We're still in the same subcategory of objects. But now it gives you a little blurb of education. Sometimes reading this can be more confusing than going right to the demo. So what I recommend to you is just look at the demo first before trying to consume this, and then come back and try to go back and read this paragraph. When I first started learning, I went right here, and I would just get so freaking confused. If I would have just spent some time looking at the code and playing around with it, because look, they have a tester. Like, you can run the code right here. The thing that I hate about this, though, is the foobar crap. I hate it so much. It's so confusing as a new developer, foobar and all that stuff. So pop in your own stuff here. Like, go in and change these values. That's why I like to use zebra, because it makes more sense to me. Animals make more sense than foobar baz to me. So that's why I threw in animal. So my recommendation to you is to take this code, take it into your own browser, and change things out. Change it to something that makes more sense to you. In my case, animals always helps when it comes to objects or cars or people or whatever, things that are really easy to understand as far as identifying what they are. So if we come over here and we come back into our animal here, you can now see we're doing the same thing that MDN does. We have our properties and our methods. So if this is the case, we should be able to use object.entries on our object. Let's go see if this works. So you can see what they're doing here. They're console logging object.entries, and they're passing in an object. So what object do we have? What are we playing with over here? What is the name of our object? If I were to copy and paste this direct line from MDN, what do I put inside of here? Animal, very good. You might have been tempted to say zebra, but it's really animal, right? Now notice it's got this number here. We'll come back to this in a second. So let's go see what this thing actually brings out into the console. So I'm going to hit run. Let me get rid of all this stuff here too. Save and run. And you can see it is quite literally my object given in entries, meaning the name value pairs that I wrote. So the first entry is zebra and the name. The second entry is weight. So this is actually given to us in an array, which we're going to talk about pretty much right after this. But did you remember how they had these kind of interesting syntax pieces over here with the square brackets? And they had a number in here? Well, that's the number position of the entry. So what is the 0th position? Based on this chunk of craziness right here, what is the 0th position going to return? It's going to return the first value, which is what? It's name and zebra, right? Together. All right, let's see if that works. Save and run. And something's going on here, though. What do you think? Anything wrong with our syntax here? So we have entries, animal. Let's go look at, remember the syntax we brought in? Do you see something different there? Yes, there's an extra. It should be inside. Well, what's happening is this is inside here. This happens all the time, like when you copy and paste something. So it's a great idea to bring in the original reference and just comment it out so that you can see and make sure that, oh, okay, shoot, I've got to bring this 0 in after, just like they did here. I've got to do the same thing. Okay, right there. That happens all the freaking time. And you're going to like kick yourself for an hour if you don't look at the original code. So please take time to bring in the original code until you feel really comfortable and then delete it. But I'll always bring in examples first. I'll comment them out, and I'll use them as a template. Don't try to be like macho programmer and memorize everything. It's so dumb. Okay, run. And there it is, name zebra. So name zebra in the 0th position. Okay, so if we go back to our second item, weight 0. Okay, so that's going to be in our next position, which is 1. So I'm going to hit run, and let's see if it gives us the next one. And there it is. Pretty sensical. So in this case, if we wanted to return entries that matched, we can use this method. Isn't that crazy? So that's kind of showing you something interesting here. Our object literal, because we wrote it in a certain syntax, gained all of these methods for free under the hood from JavaScript. So that means we can use all of these. For example, keys. If we wanted to use keys, what does it do? It returns an array of a given object's own names. So if we come back over here and we just swap this to say keys instead of entries, let's see what this does. And let's get rid of the qualifier on here and just run this thing. Look at that. Name, weight, height, habitat, eat, and run are all considered to be the keys in our key value pairs, right? Even the methods have keys. That's why we can use anonymous functions. Do you think we can use values? Let's see. Save and run. Well, I'll just hit run. And you can see, yes, indeed, we can actually access everything on the right. And then entries gives us both. Isn't that cool? We can do pretty much anything as long as we follow the rules. So make sure, now that you've read this documentation with me and you're seeing how to read it correctly, the properties and methods are always going to be on the right. Skip over the paragraph, go right to the demo, and then come back to the paragraph and try to read it after you've tried it out. Because trying things out, my friends, so much better for learning than trying to follow a textbook. The training kit is supposed to be full of code examples and not just a wall of text. The wall of text is great to come back to after you spend some time learning. Okay. Let me go hit up the questions thread and see if there's any questions about object literals. I clicked on a word and then deleted that was in front of it without moving your mouse. You can use, I was using keyboard shortcuts. So you can use shift and left click. You can use the home keyword or the home button on your keyboard will take you, or you can use insert. There's all sorts of keyboard shortcuts that you can get used to as a developer. So I was using keyboard shortcuts to do that. Can you better clarify when you can't use const and would need to defer to a let? Yeah, so if you ever need to update the value, so if there's ever a time that the right side needs to be updated, that's when you could not use a const. But I'll tell you what, the browser will yell at you when that happens. So let the browser yell at you. Don't worry about like memorizing when that happens. So if you're using const and you get an error and your console says const not allowed here, that's when you know you've got to use a let. And then eventually you'll start to get really comfortable with it and never have to worry about it again. But that takes time. Do you have to eat function, or can you say eat, or is that just a specific library I use? So when you're referencing it, you use Well, this is how you write it as a method. So maybe it's a specific library you're using. I've heard you saying ECMA as though a word and not as an abbreviation. Is this common? Don't worry about it. That's a great question. ECMA is an acronym. ECMA standard. So I don't know, this is just going through, but you can actually go through, and there's different standards, by the way. So you can go to JavaScript. I think ECMA is like what, European Computer, what is it called? European Computer Manufacturers Association. Crazy, right? Crazy that all these things don't really matter. Like knowing that really doesn't matter, but it does scratch the itch, right? It's like, oh, okay, that's where it came from. And then these standards are put together so that we can write in a certain way. I think it's a great question. But there you go. European Computer Manufacturers Association. What is a prototype? We will talk about that later. I see foo a lot. What is that? It's just a lot of instructors got sick of trying to come up with creative resolutions, and so they just started using foo and bar, which meant nothing. Foo and bar mean nothing, and so I don't know. I hate when people do it personally. It's so confusing. I'd much rather have what I don't know. I'm biased, of course. I have my own biases, but this makes a lot more sense to me than if this was foo and this was bar and this was baz. Like, I just don't like that. For me, I like seeing animal name and weight. Okay. Those are all the questions I saw. And now for our final trick, we're going to be talking about arrays. So basically, we've been just talking about fancy ways to hold information. We've talked about var, let, and const. We talked about protecting that information inside of a block of code using functions, right? We talked about function expressions. We've talked about arrow functions. We then bumped into object literals to see key value pairs with methods. And so all these things, hopefully a lot of light bulbs have been going off today with the previous learning you've done, and with all the stuff that's leading up to here. We're filling in gaps and we're getting more fundamentals. One of the biggest fundamental pieces of holding information are arrays. So an array of information is a great way to think about it. So with arrays, we can store a lot of values in a different way than we can store values with object literals. So object literals are usually inside of this name value pair. And by the way, I skipped over something pretty fascinating, which is there's another way, and it's in the training kit, by the way, so I'm not going to spend a ton of time on this, but you can use bracket notation instead of dot notation. So you can actually do this to accomplish the same thing that dot notation did. So zebra, as you can see, it works. And you can even do this with invocations as well, with methods, I should say. So I want you to go look at that in the training kit because it does matter with JSON objects. But we'll come back to this stuff more. For now, I just want to focus on dot notation because it's just cleaner and easier for new developers. But bracket notation does exist. I would be remiss if I didn't tell you to go read the training kit about it if you haven't already. Okay. So if I come down to array, and I look at what an array can be, I'm going to use just a list of fruits here. So const fruits. So you can see here, again, I'm using a variable. I'm then using an assignment operator. But instead of going to curly braces like we did before, I'm now going to square brackets. This is what an array looks like in its simplest form. Like right now, this would be considered an array if I were to log it out, even with nothing inside of it. And that's because the compiler and ECMAScript standards know that square brackets are arrays. So what the heck is an array? Well, it stores a lot of information. And order is the most important thing about an array, like in which order things have been brought in. So I'm going to say apple. Let's do orange, and we'll do watermelon, and peach. So we've got a list of fruits that we're holding inside of an array. Let's see what this looks like in its most simple form by just console logging it out. So console.log. Isn't that kind of fun to understand now that console is an object and log's a method? I think that's pretty cool. And then we'll say fruits and see what we get here. Save and run. And look at that. We get exactly what we have. Apple, orange, watermelon, peach. Doesn't seem that special, but what's special is that the computer has assigned a position to each one of those strings. And that position starts at 0. And this freaking wrecked me for a long time as a new programmer, is just getting used to computers utilizing the 0th position. So in this case, the order of the array is actually like this. So Apple is considered to be in the 0th, which is just weird to say out loud, position, and then the first position, second position, third position, for a total length of 4 items. So of course, altogether, this does equate to 4 in its length, but the position is 0. So if you tried to put something in the 4th position, it wouldn't, nothing's there. It doesn't exist. So arrays start in the 0th position. Okay, why does that matter? Well, because we can access anything inside of our array using our array syntax. So remember, arrays have these squares, right? These square brackets. Well, with these square brackets, we can actually tell it which item to grab. So the 0th position allows me to grab the apple. So if I hit save and run, you can see that only the apple has been selected by using this specific syntax here. And of course, I can go down the line. So 1, in fact, let's just grab each one of these just so we can see it in action one by one. So 0, 1, 2, and 3. Clear, save, and run. So there it is. Apple, orange, watermelon, peach. Perfect. So all of these have been given to us in the order in which they were written. Now, if I were to swap these things, so if I put peach at the front instead, it would have an impact on everything else. Notice I'm using a comma between each value. That's important. It's just like I have a comma between each value here. It's signifying that I am doing something else and something and adding new pieces to it. Okay, so if I clear this, save it, or I should save it, but run it, you can see peach is at the top, apple, orange, etc. So hopefully we're just beating this dead horse of the 0th index. But no matter how many times we do it, guaranteed it's gonna bite you in the butt later in your programming life. It just always does. So here's the thing. This is cool and all, but why is this valuable? Like, why are arrays valuable? Well, it's because going back to our MDN search, they can do so much stuff with that value. So watch this. MDN arrays. So there you go. There's my array in JavaScript. And now let's look at our properties and our methods. Look how many methods we have available to us. Wow. Arrays can do some crazy stuff. Way more than eat and run, right, with our animal object. So arrays can do so many cool things we can do with data. But let's go look at our properties really quick. We're going to get to prototype. Bear with me. That's going to be coming up on Wednesday. But for now, let's look at array.length and see what that does. So I'm going to come back to my code, and I'm going to say .length, because, right, it's just a property, just like we did with animal.name. Like, that's why we introduce object literals, so we can understand that nothing's really scary. They're all just derived from objects. It's pretty cool, actually. So save and run, and we should get a 4. There it is, because there are 4 items in our array. So that's pretty neat. How can that be really helpful to us to know the length of an array? Well, what do you think? Why would a length matter? That's right. Iterative processes like for loops, while loops, all sorts of loops. We can get iteration by going through each one of these things. Defines bounds for loops. I like that. So length, this one little property, is super valuable to be able to go in there. Now, what if I opened up my array position? What if I did something like fruits array dot length -1? What do you think that's going to return for me? Save and run. So in this case, it's watermelon. That's pretty cool. But what if I added a bunch of items? I changed this last one to say, test. Save and run. Well, it's going to give me my last item. That's pretty cool. It's always going to give me my last item. That's a nice little trick that we can use dot length for. So we always know the last item in an array. Okay. Pretty cool. So fruits, we have all these different fruits. Let me go back to just the 4 we had. And let's talk about something I want to show you that I really like. So when you're reading these methods and you're a new developer, which all of you are, these can be really confusing just by the name. Like, what the heck does for each do? Well, I think it's going to loop. I'm not really sure what it's going to be doing, but I'll click on it and figure it out, right? Like, that's life. Just got to go in and Google things. However, one thing that's really helped me is this little helpful piece. And what it does is it takes everything in English. So it tells you what it's doing in English, like reverse an array, or delimit an array, or sort in numerical order. I'll give you this link. It's in Training Kit. It's called erasing. It's from our man in Amsterdam. So in this case, I really like this reference because you can read it in English and it translates to code when you click on it. So it just takes you down to the anchor. So let's say we wanted to reverse an array. Well, you go down to reverse an array, shows you an array, and it simply reverses it. No extra fluff. I love this. This is so great. Because when you want to figure something out and you're a brand new developer, you don't even know what you want to figure out. Like, you've got all these problems you've got to solve, and you've got this huge amount of arrays that you've got to solve this with. Well, go over here first, read through some of these things, and see if they map to the problem. So in our case, reversing an array. So you can see here, it's just using this reverse array, and it's saying it's going to reverse the order. Let's try it out. So I copied and pasted it, pop it onto my fruits, and notice that it's just a method call, right? That's why it's dot syntax with a call, just like we did with eat. So let's see what happens here. Save and run. And now you can see watermelon, orange, apple, and peach. It was reversed. Yay. That's awesome. So being able to look at erasing to get the English definition first and then come into this on the second, I mean, I just love that. It bridges so many gaps. So this is one of my favorite tools for new developers and myself, even if I've forgotten. Like, man, I want to do this with an array. I'll come to erasing and I'll read through these and go, oh, that's what I was trying to do. Join 2 arrays together or something. So these kinds of things really help me understand. And eventually you'll start using arrays so much, you'll have your go-to array methods that you'll really like. We're going to dig deep on array methods tomorrow. But for today, you can use any amount, you can use any array you want, any array method you want in your assignment. I think there are some instructions somewhere nested in there where it says you're limited, but disregard those. You're not limited today. You can use any array methods you want. So if you're taking note, Nathan, take note. That's a big deal. Okay. That constitutes the ends of our objectives here. So we have talked about function definitions, expressions, arrow functions, and their differences. Varlet and const and their differences. Creating and using object literals as well as describing object properties and methods, which you should be able to do now. And create and use arrays as well as array properties and array methods. So all these things come together. It all started with a simple var, and now we've ended with array methods and all the power that be. So it's pretty crazy to see how we put all these things in the JavaScript pot and we stir them together and we start building apps from these things. Now, one thing that was brought up by one of your PMs was said, how can I understand and see these things in the wild and be able to understand how JavaScript is applied it would have really helped to see these things like being used. And oftentimes you can go to other websites. I don't know, I'm shooting in the dark here. I probably should have prepared, but pretty confident that the site's using JavaScript somewhere. So you can actually inspect. And if you want to see the JavaScript content, you can go to the Sources tab and actually look and read through their JavaScript. So in this case, you can see all the JavaScript that's being used on ESPN.com. At least they have a Disney ID.js. So it looks like, Disney owns ESPN. So they're probably doing something with like tokens and refreshing things. But at least you can see, hey, look, there's a var. Hey, look, they're setting up a timer object, and they have a key value pair of init. So in this case, without even preparing anything, just looking at this, you can see all of the JavaScript pieces. And actually, you can start reading these things. Isn't that crazy? Like right now, we just open up random JavaScript, and we can read this stuff. That's empowering. It's pretty cool. It's not as scary as maybe it would have been yesterday. It's still got some weird stuff in here, of course, but we're not worried about that weird stuff. We're just looking for things that we do know, like there's an object and there's a var. We know what those things are. Look how many lines of code. 16,967. Now that is crazy. But as we go through here, you can see they're just setting up a bunch of things, and they're using vars. Guaranteed they're doing this for cross-browser compatibility because ESPN needs to be viewed on as many sites as possible. So they're probably using Babel to transpile it down for all browsers. So don't freak out when you see var. It's all part of the plan. Okay, there you go. There's some JavaScript in the wild, but don't get caught up in it. Just understand that that's where we're going. We're going to be able to see this stuff moving more into the future. For your assignment this afternoon, I'm basically going to just have you review everything we just talked about, from the morning videos to the guided project, and then going into the afternoon. You've got an assignments folder. Notice I've got an index.html file that's referencing all of your other files using script tags. So when we want to bring something into our HTML, we use a script tag, either in the head or preferably actually right above the body tag. But for now, I'm not concerned about that. You'll just see that there's a big H1 that says, check your work in the console. So this being said, I do want to let you know about one of my favorite extensions called Quokka. This allows you to quickly see all of the code that you're writing without jumping to the browser. So that's pretty neat, right? To be able to see the result without jumping. However, for today, I would actually prefer you stay away from Quokka just for today because it's our big fundamental day. I do want you to get used to jumping into the browser, opening up the inspect tool, jumping into your console, and reading your code. I really just want you to get used to understanding that the console is part of the browser's ecosystem. I'd be really sad if you didn't do that. So I want you to go in there and use your console, and then you can start using Quokka tomorrow if you want, or at least just understand that console is how we can read that code from our code. So that is my ask to you is, yes, Quokka is amazing. Some of your project managers love it. I personally love it. But using the console proper is a great learning experience, and I want you to try to do that today. So you're going to go through here and read the README file. So I'm not going to explain everything to you, but basically, like objects.js, you're going to just get some practice writing objects. So I've given you 5 pieces of information. You've just got to make 5 objects for me and then reference them. So this is just good practice, getting in those reps. Okay. Let me hit up the questions here, and if you're feeling good, you're free to go. Otherwise, stay around and I'll answer some of these questions. Bracket notation uses double quotes and other singles. Is there a reason? No, you've just got to be consistent. So you can use single quotes or double quotes. Just pick one and stick with it. We learned that variables defined by const cannot be updated. If we define an array using const, are we able to update the array using unshift? Great question. The answer to that is the reference is immutable. So if we come over here to the code, See how we have const fruits and it's referencing these brackets? Well, guess what? It's not referencing the insides of the brackets. Kind of annoying, right? So in reality, here's a secret. It's not really immutable, right? Like I can change this stuff in here if I wanted to because it's not part of the const reference. The only thing that's part of the const reference is the array itself. Isn't that kind of crazy to think about that? Mind-blowing a little bit. So the insides of the array are totally mutable, but the array itself is not mutable. So const protects the array, allowing us to not accidentally throw in like a string. So where const is really good is if we tried to do this. Fruits assign the value of something. That would throw an error. We want that error. So that's why we like const, because we don't want this to get blown up on accident. So great question. Good thinking there. Is there a best simplified JS cheat sheet that you like, or just stick with MDN and Google? Really, it's MDN and Google. I like JavaScript info for learning. It's a Russian website that has been translated into English, and it's amazing. So massive amounts of content here, like insanely amount of content here. And the reason I like that it's from Russians is that they had to translate it into English. And so they don't have the luxury of like people using fancy translated words, and it's way more straightforward. So I actually like JavaScript info the best for when I want to get away from the MDN blues, which happens from time to time. Okay, what are the differences between arrays and objects, and when would you use one or the other? Key value pairs and objects, methods and objects, but not arrays. So the biggest difference between an array and an object is indices, right? So objects don't have built into them the ability to jump into a specific indice, right? Like that. That is illegal. That's not going to work. So like that's not going to be a valid piece. So that's a big difference right there between the two. Also, arrays are derived, meaning they inherit from objects. So objects are the OG. So these come first as far as like being made into something in JavaScript. So objects come before arrays. So arrays are actually fancy objects. And even crazier, it's going to blow your mind, is arrays are just fancy functions. That's right. Arrays are derived from functions. That's pretty crazy to think about. So these are actually a type of function. Not a type of function, but they inherit from functions. We'll talk about that on Wednesday, though. Okay. Can you put variables inside arrays? You can put pretty much, well, you can put anything inside of arrays. You can put objects, you can put variables, you can put all sorts of stuff. So yes. How come when you do .length, it doesn't return 3, even though the array counts from 0? Great question. So remember, length is the total amount of references and total amount of positions. So 1, 2, 3, 4 positions exist inside the array. So when we run fruits.length, it returns 4, even though it starts counting at 0, 1, 2, 3. So don't get confused by that. I know I did as a new developer. So remember, the .length is the total amount of items in the array, whereas the position is the 0th position. Okay? How often should we commit for today's project? I would commit every time you get something done. So if you get like all those objects done, that's a great opportunity to commit and just be like, objects done, for example. So I would commit every time you finish a portion of code. How do you view the JS of a website again? So you're going to right-click, inspect. It's any website, so we can go here, inspect, go to the sources tab, and you'll see all the JavaScript they've got available to you. You can just click on the JavaScript if you want. So it's one way you could do it. Some people obfuscate their code, making it very hard for you to read it. Others don't. Okay. Thanks, everybody. Go take a break, come back, hit your project strong, and we will get into even more good JavaScript stuff tomorrow. Talk to you later. See ya.